Hello guys, this is Jesse Precious and with you here is Jesse of us. Okay, today we're on a learning streak and we hope to solve certain past questions. Um, so let's see our browser. At least we're going to try solve 10 questions. Okay, for my students. All right. So as you can see, we have a question here, set of questions here, and I think number one, which comes from JAM 1999. Is on sets, and the number two is on logarithm. Number three is on sword or sordic expressions. Number four is on indices. All right, and I think due to the glitch, number four question is also was also repeated on the number five, and as such, once we solve for four, that accounts for five. All right, never not to worry. We're going to solve each and every of these questions as seen. All right, all I need to do is take it to my board as the case may be. All right, okay, okay. You know what? I think that this session is very helpful. Okay, hello, we have our question board. Okay, this is helpful. So let's remember how English, you understand this, and then we'll move on to other questions. Okay, there we go. All right. A group of market women sells at least one yam, plantain, and maize. 12 of them sells maize, 10 sells yam, 14 sells plantain, 5 sells plantain and maize, and 4 sells yam and maize, and 2 sells yam and plantain only. Only. Let's mark that word. While 3 sells all 3 of them, 3 of the items. How many women are in the group? All right. First, I would like to represent this with a Venn diagram. If we want to grasp the full concept of this, we usually use Venn diagram to express set. All right. So I'm drawing my first circle, and I'm hoping that the overlap doesn't confuse you. So I'm labeling the maize section with M, plantain P, and yam Y. All right. So as the case may be, we are asked to find how many women are in the group. And from what we are told, for maize section, 12 sold maize. And then for plantain section, 14 sold plantain. And then for the yam section, 10 sold yam. All right. And then there's this intersection where certain women also sold um, few things, not just one thing, but two or three. All right. So 5 sold or sells plantain and maize. So for plantain and maize, there are 5 women who sells them. And then for yam and maize, there are 4 women. And then for yam and plantain only, there are just 2 women. And then there is this 3 merchants who sells all 3 of them. So they come here into the center. We're going to start from the mid section and then spread outwards towards the Venn diagram. And maybe I could redraw something or sketch out something to explain a bit more of what we must have done. So the first thing I would like to do is find out how many women actually that sold maize and plantain. How many women actually sold maize and plantain only? Now, for you to obtain that, you're going to take this 5, which is the number, and then if you can take this as an analogy where maybe there was this census where we are asked to collect a list of women who sold plantain and maize. So when the person writes the list, she enlists at least 5 persons. And then there is also this different person who also was asked to sell to make a list of people who sold the 3 of the goods that was actually listed, and she listed at least 3. You should know that 5 in this 5, the 3 women that sold the 3 items are enlisted. So 5 minus 3 gives you 2. So actually the only women or the women that were selling just maize and plantain alone only is just 2. All right. So The next one we have is plantain and yam. How many women actually sow plantain and yam? All right, that is a no-brainer. There's a question pointed out that just two sowed plantain and yam. All right, and we can be subtracting three from two when we know that there is no way that the three women that sold all three items were enlisted amongst the two that just sold plantain and yam. All right, let's also talk about how many women that sold maize and yam. All right, four women were enlisted, and out of these four, three sold general items or sold all the three items. So we have one here. All right. So we are done here. So we are going to now obtain how many women actually sold maize only. All right. With this recent information we've obtained, we can just say, okay, 12 women was listed as people that sold maize only. And then we can take away we can take away the number of persons that sold maize and plantain, which actually we found out is two, and also we take away the number of persons that sold the three items, which is three, and then we can also take away the number of persons that sold maize and yam, everything pertaining to maize. We are actually taking away the number of persons that sold those items, just so we can find the just few persons that just sold maize only. All right, so 12 minus 2 minus 3 minus 1 would give you 6. And then for number of persons that just sold plantain only, we repeat the same. All right, so we're going to say, all right, there are 14 persons, and then everything pertaining to plantain sellers. We take away the 3 that sold general items, we take away the 2 that sold maize and plantain, and then we take away the 2 that just sold plantain and yam. All right, when this is taken away, we have 7 left. And then how many women sold just yam? Okay, only. That would be 10 women. Subtract the general, the persons that sold general items, and then we subtract every other thing that pertains to yam. All right, 1 on the other hand, and then 2 on the other hand. So we now have 4 left. All right, so we're making progress. I could resketch the diagram with the recent information obtained, and it would look something like this. Where we have maize, plantain, and yam. All right, we have just 6 persons that sold plantain, that sold maize. We have just 7 persons that sold plantain, and we have just 4 persons that sold yam. And then 2 here, 2 here, 1 here, 3 here. At least you understand how these values came to be. All we have to do in order to find the total number of persons that were in the market is by adding each and every of the values. So 6 plus 2 plus 7 plus 1 plus 3 plus 2 plus 4. And if I'm correct, that would give you at least 25. All right. And in the options, we have A to be the answer. All right. All right. So we have our next questions on logarithm, and I have just about 2 ways to solve this problem. But I'll do one which I consider most effective by just giving you two basic concepts of logarithm which we need to solve this particular problem. And the first one is we already know about how a log of a number, let's say log of a number a of base b, if it equals c, this particular log is defined by saying b to the power of c is equal to a. All right, so we are taking on this interesting perspective so that we can solve this particular problem. And another one I would like to tell you is, provided we wanted to change this particular log or the base of this particular log, we know that the base here is b, and we wanted to change the base of this log into something somewhat we call x. Doing that would entail you say log of a number, log of a number a of the new base x all over log of the initial base b of the new base x. That will not give you the new expression to be something log of a in base x. All right, log of a in base x. All right, pardon. Okay, so as I was saying, that would give you log of a in base x. All right, so the next thing we're going to do is, having established these two rules, we're going to use it to solve this problem. So we are asked to find the log. Oh, okay, we're asked to say, okay, the question goes this way. If log of 10 of a base 8 is equal to x, evaluate log 5 of base 8 in terms of x. We are going to express log 5 of base 8 in terms of x. How do we do that? I'm going to first of all initiate the first law here, which says if we had log of a number 10 of base 8 equal to x, it is the same thing as saying 8 to the power of x is equal to 10. All right. Now that we have this particular expression well elaborated, we're going to find a way 5 relates to this expression. And we all know that 5 is a factor of 10. So if we said 2 times 5, that would give you 10. And then we have here log, okay, we have here 8 to the power of x equal to 2 times 5. All right. Now the next thing we are going to do is we are going to make 5 subject of the formula. Making 5 subject of the formula would entail that you divide through with 2. All right. Dividing through with 2 would have, all right, I would like to take you on this in a different board. All right. Like we were saying, log 10, 8 equal to x. 8 to the power of x equal 10. 8x equals 2 times 5. 5 is equal to 8 to the power of x divided by 2, of which we are dividing through by 2, or we divided through by 2 in this section. All right, divided through by 2. All right, now further expanding this, we all know that the exponential representation of 8 would be 2 to the power of 3, and then we can place the x which is above it before now, all divided by 2. And then the next one we have is we have, okay, we don't really have to change the 8 as the case may be, or I could say, all right, 2 to the power of 3x minus 1. This is an initial law. The 2 has been taken away, all to replace the negative 1. So in this case, we are going to say that 5 is equal to 2 to the power of 3x minus 1. All right, let's say applying log to both sides. Applying log to both sides in base 8. All right, applying log to both sides in base 8. That would be log 8 of 5 is equal to 2 to the power of 3x minus 1. All right, so the next thing we're going to do is, sorry, we didn't apply the log on this side. So we have here log base 8 to 3x minus 1. All right, we already know the initial law where the logarithmic law where this has to multiply this. This is a power. So we have here 3x minus 1 all in the bracket log 2 of base 8. Alright, all equal to log 5 of base 8. So the next thing we're going to do is we're going to say, alright, let's change this into something we can solve. Changing the base of this log so that we can simplify the value of log 2 of base 8. We're going to have something like this. I'm changing it to a new base 2 because that's the only way we can simplify it. 2 goes for both 2 and 8 as well. So we have here. So log of a number of same base is same as 1. And as the case of maybe if we were to follow the definition of log, find out that log, I'm just going to do this as an extra, log 8 of base 2 is equal to an unknown which we call x. 2 raised to the power of x is equal to 2 raised to the power 3. In other words, x is equal to 3. So the value here is going to be 3. In other words, you're going to have 3x minus 1 all in the bracket 1 over 3. 1 over 3 breaks the bracket. We have here x minus 1 over 3. In other words, log log 5 of base 8 is equal to x minus 1 over 3. Alright. Then heading back to the initial, we have our answer to be equal to C. Alright. So the next thing we might be talking about is the Sodic expression. For the Sodic expression, where we have find the value of x if sod or if root 2 over x plus 2 plus x over x plus root 2 is equal to 1 over x minus root 2. So if we were to find the value of x, the first thing I will always suggest is to cross multiply. Alright, we cross multiply where everything here gets to multiply the numerator. So we have here root 2 all in the bracket x minus root 2. Bracket close. The next thing we're going to do is we also do the same here where 1 multiplies everything here, of which 1 multiplied by anything gives you that same thing. So we have here x plus root 2. Alright, we break the brackets for the left hand side where we now have x root 2 minus root 2 times root 2 would give you root 4, of which root 4 is the same thing as 2. Square root of 4 is the same thing as 2, equal to x plus root 2. Alright, the next thing we're going to do is we're going to collect like terms. For everything that has x on it, let's take it to one side. Alright, so I'm going to subtract x from both sides. Subtracting x from both sides, we have here x root 2 minus x, and then I'm adding 2 on both sides, and then is equal to root 2 plus 2. Alright, so we factor out x as the case may be. So we now have x all in a bracket root 2 minus 1 bracket close is equal to root 2 plus 2. Alright, so since we are looking for the value of x, we are going to divide through by its coefficient or its Sodic expression, which is root 2 minus 1. Alright, that will now give you something like this. X is equal to all over Alright, the next thing we're going to do is to rationalize. We have to rationalize this to make it look like what we have in our option.